Good morning, Sar. Um, Before I addressed your specific questions, I want to talk briefly about just kind of what a permutation is, the first three lessons on the quiz, and what a combination is, the next three lessons on the quiz. And because they look very similar when you actually do the math, but uh, as a concept, they are a little bit different. So before I answer questions, before I go do examples, a permutation is kind of like a race. So I'm going to put race here. I'll maybe text you these notes when I'm done with them. But a permutation is a race. So if you had, let's say, 5 people running a race, a foot race, and you really only cared about first, second, and third place, because fourth place they lost, they're done. So you really only care about first, second, and third out of the 5 people who are racing. There's lots of ways that race could end, right? You've got 5 people. The first, well, this is going to sound really weird. Let's say, let's say you have person A, B, C, D, and E. I'm tired and I'm feeling lazy, so I'm not going to be very creative. We got our 5 people. You could have A finish first, and then B, and then C. You could have D finish first, and then E, and then B. It could be A, C, E. You get the idea that there's lots of different ways that this race could end for first, second, and third place. I'll also say that having A first, B second, and C third, that's different than having B first, C second, and A third. Same 3 people, but this is a very different finishing than this is. If you bet on A to win, you did not do well because A got third place. So this is a different organization of those 3 people, or a different ordering, excuse me. So that's a permutation. The way you figure it out is with this formula, n factorial. So just to say that briefly, the exclamation point is factorial, and that is asking how many ways can you rearrange everything. So we've got our 5 people. This is kind of the permutation piece there. We have the same 5 people, and we want to know how many ways could you rearrange all 5 of them. Let's see, for the first 2, 3, 4, 5, you got 5 places, 5 different people. The first place could be any of those 5. So you have 5 choices. This is really more about choices than anything. So choices is factorial. That's the exclamation point. Super excited numbers. You have 5 choices for the first spot. Once you've picked one of these numbers for the first slot, you really only have 4 choices left. You picked, I don't know, C for the first spot. Now you only have 4 choices. So the number of choices you have for the second position in our 5 places is only 4. So you pick another one. Now you only have 3 choices. Now you only have 2 choices. Now you only have 1 choice. And if you multiply all those choices together, you're going to get a number. I kind of want to figure it out, actually. I think it's going to be 120. There we go. Yes. I don't like to leave a question unanswered for whatever reason. So we got 120 different ways that you could rearrange 5 different people. The permutation only asks about a certain group of them, a certain subset. Only first 1, 2, 3. Because first, second, and third place are the only ones that matter, apparently. But that's the difference between factorial and permutation. So going back to the real notes, permutation is n factorial, and I'll explain what that n means here in a second, divided by n minus r factorial. N is the total number of options you have. R is which ones you're choosing. It's the size of the subset. So I said that we had, in my example of A, B, C, D, E, I said that we had 5 people running the race, and I only cared about first, second, and third place. So I'm going to do 5 factorial divided by 5 minus 3 factorial. And I'm actually going to do a little bit of work here in my head. And that's going to be 60. I'll use a calculator later so you can see how, how to do that without using your head. But that's going to be 60. A combination. The only difference between a permutation and a combination is that in a permutation, the order matters in a race. First place and second place are different. A combination is a small group. I'm putting it in parentheses because it's not technically a small group, but that's a good way of thinking about it. Just like a permutation isn't technically a race, but the order does matter. And a race is an easy way to think about it. Small group is an easy way to think about a combination. In a small group, it doesn't matter who gets chosen first. If I'm choosing 5 people from my classroom, it doesn't matter who I'm choosing first. They're all coming with me. We're all going on a field trip, the 5 people I choose. So I'm going to choose 5 out of the 20 people in my classroom to go on a small field trip with me. It doesn't matter if I choose you first, Sar, or if I choose you third. You're still coming on the trip. So the order does not matter in a combination. The only difference between the formulas is this extra r factorial, and I'm not going to get into where that comes from right now. So that ends up being the formula for a combination. So let's say instead of getting first, second, and third, I'm just choosing. Oftentimes you'll see the word choose with a combination. So let's say I choose 3 out of my 5 runners to get ice cream. I don't know. Again, it's early. My creativity is low. So now I'm going to go 3 factorial and 5 minus 3 factorial. And that's going to be 10. It's a lot fewer because, again, the order doesn't matter. With a permutation, these were 2 different orders, 2 different finishing for that race. In a combination, it's the exact same people. So this is a duplicate, and we don't count the duplicates because it's the same people. I'm choosing the same people. So you're going to get fewer choices with a combination, and you're going to get higher one with permutation. All right, so that's a combination. That's how the formula works. Let's look at an example. All right, number 2 on this problem here, or on this assignment, excuse me, says how many different menus showing 10 main courses can a restaurant make if it has 15 main courses from which to choose? So I'm choosing 10 main courses. It's a big group of people that are, they're all going to share dinner or something, and they have 15 courses to choose from. So I'm going to use this calculator here. I Googled Desmos scientific calculator. The Google calculator will work. This one is just going to show it in the same way that I wrote it down. So it just looks the same as the way I was writing it. So if I fill in that formula, I don't know if I'm going to be able to do this well. I don't know. We'll see. So here's the formula for the combinations. N factorial. Remember, n is the number of choices you have in all. R is the number in your subset. It's how many you're choosing. So there are 15 main courses, 15 factorial. I just use the keyboard, but there is a factorial button somewhere. Just use the keyboard. There is a button for it, but I would just use the keyboard. Shift 1 is the exclamation point. Okay, so we've got 15 factorial divided by, let's see, the formula says I do r factorial. So r, there were 10 menus or 10 choices that I wanted to make, exclamation point, factorial, parentheses, n minus r, close the parentheses. If you don't close the parentheses, if you don't fill in the formula exactly the way it's written, then you're going to get the wrong answer. So you do need parentheses where there are parentheses. And there it is. There's the answer, 3,003. So there are 3,003 different ways that you could choose 10 main dishes from 15 main dishes to choose on the menu. Okay. Hey, that was your answer. 3 is basically the exact same question. How many different menus can be made showing 5 main courses from 15 choices? So the only thing I'm changing here is instead of 10, I'm going to put 5. And still 3,003 in this case. And you could do the arithmetic. You could work out why that's true. I'm not going to do that here, but it does work out to be true that there are still 3,003 different ways that you can make that choice. And that's how you do most of these questions. In fact, the ones you asked me about, I lost it. Oh, here we go. Numbers 3, 8, and 11 are all basically the exact same problem. You have some number of things that you can choose. You choose a small group of them. That's how many there are. Plug it into the formula, combination, and you're done. There was one other question you asked me about, and that was, I think it was number 5. Asked about number of subsets. I'm actually going to stop this video. I'll make a separate video because this is getting long on how to calculate the number of subsets.